Okay. Question 7 or 8, anyone having a doubt or a question? 7, 8. The tube instrument, Ahmad, can be a open pipe, it can be a closed pipe. When we have a mouthpiece, and we maintain a node there, it means it will be considered as a closed pipe. Whenever node is formed at any one of the end, it will be a closed pipe. Because, like example, we have the tube instrument and here is our mouth. So we close this part. So now it will be a closed instrument, like closed pipe. If it, like example, we have a straw and we blow the air. So as a result, now we'll consider this straw as an open pipe. Question 7, 8, no doubt. Question 9, 10. Question 8. In question 8, transmitting mass sends out microwave of a wavelength of 1.5 centimeter and a radio wave of wavelength 1.5 kilometer. So longer wavelength diffract more as compared to the shorter wavelength. Look, how in a just I will answer one question from the student, that how a standing wave is produced here. What will happen when we blow the air in this? We cause a vibration. So these air particles are vibrating in the tube. When these air particles are vibrating in the tube, so they are colliding with each other. Some places, because it's a longitudinal wave, and how standing wave is produced when two waves are produced in opposite direction, it will give rise to a standing wave. So when we blow the air from the surrounding, the reflection will happen. So as a result, we blow and the surrounding, the air particles are coming inside. So this will lead to a formation of a standing wave within the closed tube. So the disturbance in the air is actually traveling in both directions. This rise to a standing wave. As we know, longer wavelength diffract more than the shorter wavelength. So a receiving aerial behind a mountain can detect radio wave, but not the microwave. As you can see, microwave is having a shorter wavelength. Shorter wavelength diffract less. Longer wavelength diffract more. So what could be a reason for that? Say this is a signal produced. So as a result of a diffraction, the aerial can receive those signal. Microwaves, because they have a shorter wavelength, so diffraction of a microwave, it will diffract, but a very small amount of diffraction. So the aerial cannot receive or pick up the signal. But radio waves, which are having a longer wavelength, as a result, the longer wavelength diffract more. So the aerial can receive those signal. So the radio waves are diffracted around the mountain, but the microwaves are not. And how we identify that? Because the wavelength is already given, or radio waves have a longer wavelength than the microwaves. No, not smaller wavelength, longer wavelength diffract more than the. When a diffraction around the edge, the longer wavelength diffract more. The shorter wavelength diffract less. Question 10. 9 and 10, any doubt? Question 10. The diagram shows a screen that is at a distance L from a diffraction grating. The grating has a total number of lines N. Any two adjacent lines are distance a D apart. That's the spacing. And a beam of a light parallel of a wavelength lambda is incident on a grating element. Which quantities affect the distance between the first order maxima on the screen? So we have the formula d sine theta is equals to n lambda, where n is the order of image. Like first order, second order, lambda is a wavelength, d is a spacing, and this is the angle between, like theta, this theta is there. So we simply want to relate, like sine theta is related to n lambda over d. This is one of the formula. And there's also another formula, if you recall, that lambda is equals to ax over L, or you can also use dx over L, where d, the distance x is, yeah, they're asking this distance x, okay? And this distance x will change if the angle will also change. Now we have the two formulas, that lambda is equals to ax over, why we have the two formulas, lambda is equals to ax over d, and we have d sine theta is equals to n lambda. From the first formula, we can see the angle depends on the order of image. If we increase the order of image, but in the question, we are talking about the first order image, so this is constant. This is not changing. If we change the wavelength, what will happen? Like if we use a longer wavelength, so diffraction will be more, so the value of sine theta will also increase. So it means if the theta will change, the spacing definitely will change, because the spacing between the first order maxima, if you take like this as x, so if this half of this is, we call that as x, if this changes, it means the spacing, if angle changes, the spacing between the first order maxima will change, or if the value of x changes, the angle, the spacing will also change. So what about d? As you can see here, if the value of a d will affect the sine theta, as it is included in the formula. Like if we increase the value of a d, the angle will decrease, and opposite will happen. If we increase the value of a d, the angle will decrease. So means yes, the d will affect. What about the lambda? The lambda we just discussed, that will also affect. What is, yeah, they're asking about they're asking the first order maxima, this total distance. But if the half of the distance will change, definitely the total distance will also change. So we can just work out for half of the distance, and we can compare that the total distance will also change. So the value of the x, if we change the lambda, it is changing. If we change the d, it's also changing. Now the next form, what about n? What is n? N is a number of the lines. The grating has total, and how we get the value for a D? D is the total length of the grating divided by number of the lines. That's how we work out D. So if we change the value of n, if the value of n is increase or decrease, so the D will change. And if the D will change, the angle will also change. So it means the value of the L and the value of the n is also affecting the value of theta. What about L? As you can see here, how it is related. If we change the value, so what will happen if you see, because what we are doing, we are comparing with two formulas, that d sine theta is equals to n lambda, and we are using another formula, that lambda, because the two formulas are there for this, lambda is equals to ax, or you can also say dx divided by L. So this is x, d is the spacing between the slits, x is the spacing between from the center to the order, first order or second order. So this theta, like sine theta, is equals to n lambda over d. If I change lambda, the sine theta will change. If I change d, the theta will also change. And if I change the number of the lines, because d is the total length of the grating element divided by number of the lines. So if I change n, the d will change, and if the d changes, the theta will also change. And what about L? As you can see here, lambda L is equals to dx. So if I change L, the x will also change. So all of these If we take, so d sine theta is equals to n lambda. That is one of them. And we have d is equals to the total length of the lines divided by the number of the lines or value of the n. So which quantity affect the distance between the first order diffraction maxima on the screen? Now, the first order maxima, as we have d sine theta is equals to n lambda, so sine theta is equals to n lambda over d. If we were changing the d, we can write this formula that sine theta is equals to n lambda over d. So if we are changing the value for d, the angle is changing. Okay? Like the theta will change. So this is yes. If we change the lambda, if the lambda is changed, what will happen? The theta will also change. Then we have the order of the image. N is the order of image, which is 1. L is the spacing. If we change, like example, if the screen is closely placed here, if you reduce, like place the screen closer, you can clearly see the value of x is changing. Like this is x. This will be x. This will be x. This will also be x. Is it clear till this point? Then what about the last value? Yeah, what about the last value? The grating has a total number of lines n. If a grating has a total number of lines L, n lines are there, right? That's the total number of the lines which are present. The spacing between the lines can affect the diffraction pattern. Like example, whether a diffraction happen or no. So this, the grating has a total number of lines n. It can have 200 lines or 300 lines. But the diffraction of a light depends on the spacing between the slits. Like example, if I have the slit, it's not about the number of the lines, it's the spacing of the slit. If I change the spacing between the slits, if we have a small spacing between the slits, then the diffraction will be more. If we have a large spacing between the slits, in that case, the diffraction will be less or a smaller diffraction will happen or occur. So it's not about the number of the lines, it's a opening of the slit that will affect the diffraction pattern. So that's why n is not included in the diffraction pattern. Is it clear? Like, because there's a spacing of the slit, it's not about the number of the lines. I may have different number of line, like I have say 1, 2, 3, 4 lines are there, okay? And I have another slit which is having, I have another slit which is like example 10 lines are there or 10 openings are there. But the diffraction depends on this gap size. If we change the gap size, only that will affect the diffraction. It's not about 100 lines or 200 lines. If the gap between the lines remains same, the diffraction pattern will remain same. So the opening of the slit that affect the diffraction here rather than having more number of the lines on the grating element. Is it clear, this concept? Any doubt in this? No doubt? Okay. Question 11. Question 11 or 12. Question 11 and 12. At a distance d from a point source of a light, intensity is I. Which of the following expression give the light intensity at a distance 2d? So if we have a source and at a distance d, we have an intensity I. The question is, if we double the distance, what will be the intensity if the distance is double at which we are observing? So what is the relation between the intensity and the distance? Because intensity is power acting on unit area. Like we have a source with a constant power. So intensity is power divided by area. When we talk about the area, intensity is not calculated at a certain point. It is calculated for a whole area. So this distance d, when we work out, like there will be lot of points which are distance d from the source. So as what it will make a sphere. So we can say then intensity will be equals to power 4 pi d square. Why we are taking area as 4 pi d square? Because it will make a sphere. So area of a sphere is 4 pi r square, where r is the radius. So in this case, the radius is equals to d. Because whenever intensity, look, we have a source and they're saying that at a distance d from the source, the intensity is I. So at a distance d from the source, intensity is I. So there is another point which will be a distance d. There will be another point which is at a distance d. So there will be a lot of points which are at a distance d from the source. So when we combine all those points, what it will make a 3D structure which will be a sphere. So all the points which, in this case, all the points will be at a distance of d from the source. So this S is representing a source. So what it will make a sphere. And intensity is power acting on unit area. So power divided by area. And what is the area of a sphere? Area of a sphere is 4 pi r square. And because in this case, the radius of a sphere is d, so we can say power divided by 4 pi d square. That is if the distance is d. But what if in the question, the distance is 2d, like doubled? So if a distance from the source is d here, and the distance from the source is 2d. Here intensity example I, and here also we say I dash because a new intensity. So according to the formula that I, the intensity here will be equals to power divided by 4 pi d square. But according to the intensity, the new intensity here will be power divided by 4 pi 2d square because the distance is double. The power of the source which is used here is same, like same source is emitting out. So we can say that intensity into 4 pi d square is equals to power of the source. And here also the new intensity is equals to 4 pi 2d square equals to power of the source. The same source is used, so it will have the same power. So we can compare the two equations, that the new intensity at a distance of 2d will be equals to 4 pi 2d square. And the first intensity was I at a distance of 4 pi d square. Distance is, now we simplify this, 4 pi will cancel with 4 pi. And this is the new intensity which is equals to 4d square. And this is the original intensity at a distance d square. So now d square will cancel with d square. D square will cancel with d square. So what is the new intensity? The new intensity is the original intensity divided by 4. So it will be a quarter of the, I can do this question directly, or you can also, we cannot convert, no, I dash and I cannot be cancelled out because this intensity is different from this one. The two intensities are different. The source has a power of a P and the intensity at a distance d is I. And the source has a power P and the intensity at a distance 2d is I dash, a new intensity. These two intensities will not be same. So as we move away from the source, the intensity will decrease. And it follows the inverse square relation. If the distance is double, if a distance is double, the intensity will decrease by 4. If a distance is 3 times, intensity will decrease by 9. If a distance is 5 times, intensity will decrease by 25 because it follows inverse square relation. Is it clear, this one? Or should I repeat? So, a quick revision, like I will repeat, a source is there at a distance of d, the intensity is I. Same source at a distance of 2d, intensity is I dash. So here the intensity was 4, the power of the source divided by 4 pi d square. Why d squared? Because in this case the radius is d. It's not diameter, it's a radius, but the distance d is given. And here the intensity is power divided by 4 pi 2d square because the distance is twice. So we just compare because the same source is used, so the power will be same. Question 12, any doubt? Two polarizing filters X and Y are arranged between the light source and the observer as shown. The intensity of the intensity of a light reaching an observer is maximum. The observer rotate the filter X. Area of the sphere is pi r square and area of a cross section is pi r. Area of a sphere is 4 pi r square and area of cross section. Like example, if I have a wire, what is the area of this part? I will use the formula pi r square. But if I have a sphere, what is the area, the total area of a sphere? It is 4 pi r square. So when the polarizing, like right now, the light intensity is maximum. The observer rotate the filter X, so he's rotating this filter, then rotate the filter Y, so the intensity is maximum again. Which row shows a possible angle? Look, right now, say this is, he's receiving the maximum intensity, so two polarizing